Worldwide, these are the basic units of measurement that we use. They're international units. So with regard to length, and they're metric, not so surprising, we use the meter for the basic unit of length. For the basic unit of mass, we use the kilogram. So we'll talk about what kilo means, kilogram. Just kind of remind you maybe if you're familiar with that. For time, we talk about the basic unit is a second. And for temperature, we use actually the Kelvin temperature scale. Remember, absolute 0 Kelvin, we use the Kelvin temperature scale, internationally speaking, for all of our sciences. Very good. So these are all, I'll let you take a look at them, and then I'm going to ask you a question about, the question is going to be, what are these measuring of those three quantities? Is it length, mass, volume, or time? So, I don't know, volume was anyway. Here we have some different glassware. This you probably recognized. I'll put B for beaker. We're probably pretty good with that. This is, you have a couple of these in your drawer. This is kind of nice. Notice that the marks are a little bit closer together. I'll put C for cylinder because that's what that is. Now these marks, I didn't mention it when you check in, but these marks are actually called gradations. Gradations. And so the gradations give us, tell us the quantity of liquid we have in there. So notice that these gradations seem closer together, so you would think you'd have a better shot at getting a more, and we'll talk about accuracy and precision, but you would think that your precision and maybe even your accuracy would be better in using a cylinder. You don't have one of these in your drawer, but this is called a pipette. Pipette. One of the things I mentioned in my safety rules was never, if you're going to fill a pipette, never suck a pipette with your mouth. Go ahead and use what we call pipette bulb. Pipettes oftentimes just have one mark up here, and that's their one gradation. And that's similar with this over here. This is pretty, isn't it? This is called a volumetric flask. You guys have Erlenmeyer flasks in your drawers, but this is a volumetric or a V flask with just one mark at the top, pretty precise. And this last thing over here actually is called a burette. And not sure if we'll get to using those this semester, but what a burette does is, here's this little stopcock, and it basically, you drip this solution into the beaker in small amounts, and you can see what the measurement up there is. So which measurement are these? What do these all have in common? Okay, so I've got a couple of videos to kind of show you in chemistry why, a couple of reasons we are kind of particular about measuring things. Maybe it worked a minute ago. This one, as it's coming up, I'll kind of let you know. I know a lot of you are kind of interested maybe in chemical reactions. A lot of times for a chemical reaction, we need to have a certain concentration of the liquid, of our solution. And so this little video is going to kind of talk you through things that we consider when we're making up those solutions. Here we go.
To prepare a solution of known concentration, we must first weigh the solute. We need an accurate volumetric flask designed to hold 250 milliliters. We first add the solute to the empty flask. The flask is filled about halfway with water and mixed to dissolve the solute. We add water in stages. Combining all the solvent with the undissolved solute in one step can lead to inaccurate measurements. We mix again. The solution is prepared.
So maybe you kind of saw that mark in the top of, this is the volumetric flask we looked at a minute ago. And so everything's really kind of precise. Some chemical reactions are more persnickety than others. Let's see, this next one uses a burette. There we go.
Here a sodium hydroxide solution, whose concentration is accurately known. is being added to a burette before titrating an acid of unknown concentration. The volume of sodium hydroxide solution in the burette is estimated to 2 decimal places. The sodium hydroxide solution is added slowly to a solution of the unknown acid in a flask. The acid solution also contains an indicator, whose color will change to pink when the acid has been consumed. As the acid begins to be depleted, some color change is briefly visible. The equivalence point in the titration has been reached when the last drop of sodium hydroxide solution turns the indicator to a pink color that does not fade with time. The volume of sodium hydroxide solution in the burette at the end of the titration is estimated to 2 decimal places. Now we know the volume of sodium hydroxide solution used in the titration and can calculate the number of moles of acid that were in the flask.
So this talked about being able to use the volume, what we call the titration volume. In this case, it's looking like what, 20, not quite 24, so 23.91 maybe milliliters was dispensed from the burette. We do in chemistry labs, there's a lot of chemistry labs out there that what they do is just test for purity, or they test for impurities, they test for environmental, their quality analysis, things that we maybe take for granted that are very important being done in the chemistry benches. So let's see. It's gonna let me go on? Yes. Okay. So abbreviations, they are case sensitive, and notice that if you have more than one, you don't include the letter S. Okay, so oops, sorry about that. So G is the abbreviation for grams, M is the abbreviation for meters, L, and it's got to be an uppercase L, is the abbreviation for liters. Okay, S is the abbreviation for seconds. And if you have, if you're talking about volume, a lot of times you can talk about length cubed, and so cubic meters is meters raised to the 3rd power. I have one more slide, just again about the units. So make sure, for instance, that liters is a capital L and meters is a lowercase m, just like you saw on the previous slide. So case does make a difference. And we'll be kind of looking for I will be looking for that from you throughout the semester. We don't use a period. We don't use a period. Period. Okay, and like I mentioned before, like if you're talking about 5.3 grams, you just put 5.3 G. Okay, so